Alright, this is the final key for the Semester 2 reviews. This is Learning Target 10 for logs. With logs, remember they're the inverse of exponential functions, so we're going to rewrite these as an exponential function and then plug in values for y to find x. So the first thing we want to do is take our base to our exponent, which becomes 3 to the y power equals x minus 2. Then we're going to add 2 to both sides. So x equals 3 to the y power plus 2. We're going to plug in values for y. Since there's nothing being added or subtracted to y up here, we're going to use -2, -1, 0, 1, and 2. So if we plug that in, we get 3 to the -2 is 1/9. 1/9 plus 2 is 2 and 1/9. If we plug in -1, you get 2 to the 1/3. 3 to the 0 power is 1 plus 2 is 3. And then if we plug in 1 and 2, we'll get 5 and 11. So now we're going to graph these. Remember, we're going over x and then up or down y. So over 2 and 1/9, down 2. Over 2 and 1/3, down 1. Over 3, down 0. Over 5, up 1. And then over 11, up 2. So the graph flattens out at x equals 2. That's our asymptote. Our x-intercept is where y is 0. So 3, 0 is our x-intercept. For these, range is always all real numbers. Now domain is from the asymptote to infinity. So it's going to be 2 to infinity. For number 2, remember that natural log equals log base e. So now we've got e to the y power equals 2x. We're going to divide by 2, or you can multiply by 1/2. So 1/2 times e to the y equals x. Again, we're going to use -2, -1, 0, 1, and 2. If we plug those in, you can type those into the calculator, so it's e to the -2 power divided by 2, or times 0.5, so that's 0.07. If we plug in -1, we'll get 0.18, 0.5, 3.7, and 10. So now we're going to plot those points over 0.07, so just to the right of 0, down 2, over a little bit more, down 1, over 0.5, down 0, over 1, 2, 3.7, up 1, and then over 10, up 2. So with this one, the graph approaches x equals 0, but never crosses or touches. That's our asymptote. The x-intercept is 0.50. Range, again, is all real numbers, and domain is 0 to infinity. For this one, we have to do a little bit more to move things over, so we're going to add 2, which gives us y plus 2 equals log base 5 of x plus 3. Now we're going to go 5 to the y plus 2 power equals x plus 3. Then we want to subtract our 3 over, so x equals 5 to the y plus 2 minus 3. So if you notice, the number in parentheses goes at the end. The number outside the parentheses ends up being attached to the exponent. Since we're adding 2, we want the value up here, once we plug in x, to be -2, -1, 0, 1, and 2. So we're going to plug in -4, -3, -2, -1, and 0. When we plug in -4, we get 5 to the -2 power minus 3, which gives us -2.96. If we plug in 3, or -3, -2.8. If we plug in -2, that's 5 to the 0 is 1, minus 3 is -2, and then finishing up we get 2, and then 22. So remember, when y is 0, that's our x-intercept, so that's going to be off the graph at 22, 0. We're going to go to the left, 2.96, down 4. To the left, 2.8, down 3. -2, -2, +2, -1, and then 22, 0. So our graph is going to look like that. So now it's approaching -3. So our asymptote is x equals -3. Our domain, or our range, is all real numbers, and our domain is -3 to infinity. Final problem number 4. We're going to subtract 4, so y minus 4 equals natural log of x. That's to the base e. So e to the y minus 4 equals x. Since we want that to equal -2, -1, 0, 1, and 2, we're going to plug in 2, 3, 4, 5, and 6. And then we're also going to use 0 to find our x-intercept. If we plug in 0, we get e to the -4 power, which comes out to 0.018. So that's our x-intercept. If we plug in 2, use your calculator to come up with 0.14, 0.37, 1, 2.7, and 7.4. So over 0.14 up 2, over 0.37 up 3, over 1 up 4, over 2.7 up 5, over 7.4 up 6, and then we've got our intercept there. The asymptote is at x equals 0, range all real numbers, domain 0 to infinity. Number 5, we're going to subtract 2. Y minus 2 equals log base 2 of x plus 1. 2 to the y minus 2 equals x plus 1, so then subtract 1. 2 to the y minus 2 minus 1 equals x. So I'm going to go through this one kind of quick. We're going to plug in 0, 1, 2, 3, 4, and 5. So if we plug those in, we get -3/4, -1/2, 0, 1, 3, and 7. So we're going to plot those: -3/4, 0, -1/2, 1, 0, 2, 1, 3, 3, 4. And the 7, 5. So our asymptote is going to be at x equals -1, intercept at -3/4, 0, range all real numbers, and domain -1 to infinity. And this last one, we're going to have x equals e to the y plus 2. Plug in -2, -1, 0, 1, and 2. We get 2.14, 2.37, 3, 4.7, and 9.4. Range is going to be all real numbers. We're going to get x equals 2 for the asymptote, 3, 0 for the intercept. Range is going to be 2 to infinity. And if we plot this, our graph looks like this. And so one thing, if you've noticed, x plus 1 here, our asymptote is at -1. X minus 2 here, our asymptote is at +2. So the asymptote is at the opposite of that number inside the parentheses. Moving to our story problems. Doctor estimates we have 1 million bacteria. So our starting value is 1 million. It's decreasing, so we're going to use y equals a to the 1 minus r times to the t power. A is 1 million. R is 0.15, and it is decreasing. We want to know when y equals 100,000. So 100,000 equals 1 million, 1 minus 0.15, and we're solving for t. So if we divide by 1 million, one-tenth equals 0.85 to the t power. We're going to rewrite this as a log, so log base 0.85 to the 1/10, or of 1/10, equals t. We're going to use change of base, so you're going to go log of 1/10 divided by log 0.85 equals t. So our time is approximately 14.17 days. Now we're using a credit card to buy $8,600 worth of appliances with a 21% rate compounded continuously. So A equals P times E to the RT. P equals 8,600. R equals 0.21. A equals 10,000. So we're going to plug that in. 10,000 equals 8,600 times E to the 0.21 times T. We're going to divide by 8,600. That gives us 50 over 43 when we reduce that fraction equals e to the 0.21t. Rewrite that as a natural log. So natural log of 50 over 43 equals 0.21 t. Then we're going to divide by 0.21, and t approximately equals 0.72 years. Population of ants is growing. It starts at 30. It is increasing 0.5 or 5% every month. So we want to know y equals a times 1 plus r to the t. Our starting amount is 30. Our rate is 0.05. And our final amount is 150. We're looking for t. So 150 equals 30 times 1 plus 0.05. That gives us 5 equals 1.05 to the t power. So log base 1.05 of 5 equals t. If we calculate that out, we get almost 33 months. So now with solving, we want to get everything over, isolate the log, get the log by itself on one side, and then we're going to convert that to exponential form. So plus 6. So natural log of 3x equals 6. We're going to rewrite that as e to the 6th power equals 3x. Divide by 3. So x equals e to the 6th over 3, which equals approximately 134.48. Number 11, we're going to rewrite this, so log base 10. 10 squared equals 3x plus 1. That's 100 equals 3x plus 1 minus 1. And divide by 3. X equals 33. Number 12, we're multiplying by 2, so we're going to divide. Natural log of 3x equals 2. Remember that's base e, so we're going to go e squared equals 3x. Divide by 3. And we get approximately 2.46. Number 13, start off by dividing by 2. E to the 5x equals 22.5. Now we are starting in exponential form, so we're going to rewrite it in log form. So anything base e is natural log. Natural log of 22.5 equals 5x. We're going to divide by 5. So x equals natural log of 22.5 over 3, which approximately equals 6.23. Number 14, this is where we want to get our bases the same. So remember 1/16 equals 1 over 4 squared. We want to get this with a base of 4, so we need to move that up. So that equals 4 to the negative 2 power. So now 4 to the x minus 3 equals 4 to the negative 2. Once we get that, then we can set the exponents equal. then solve for x, and we get x equals 1. Number 15, we want to get the exponent by itself, so 5 to the x plus 2 equals 4. We're going to rewrite this now as a log. So log base 5 of 4 equals x plus 2. We're going to write that as log of 4 divided by log of 5 minus 2 equals x, and we get x equals approximately negative 1.14. Number 16, when both sides have log with the same base, then you can set the values equal. Since both are natural log, we can say that x plus 4 equals 7. Subtract 4 and we get x equals 3. And then same thing here, 3x minus 4 equals 2x plus 5. Both sides have log base 2, so we're going to subtract 2x. And then add 4. X equals 9. And our final page, both sides have natural log, so we can again set the parentheses equal. We're going to subtract 1/2 x. So that's 6 halves minus 1/2 is 5 halves. We're going to add 7. Now if we multiply both sides by 2/5, we get x equals 4. Number 19 is similar. Both have log base 10, so x plus 5 equals 3x minus 2. Add 2. X plus 7 equals 3x. Sorry, we're going to subtract x. Got ahead of myself there. And then divide by 2. X equals 7 halves. Number 20, we've got exponential exponents on both sides, so base of 3. Whenever the base is the same, you can set the exponents equal. So x equals -4. Number 21, we need to get them the same, so 8 is going to be 2 to the 3rd power. Remember 1/4 equals 1 over 2 squared. We want to move that up, so that equals 2 to the -2 power. Distribute our new exponent, so 3 3x minus 15 equals -4x minus 6. We're going to add 4x. Add 15. 7x equals 9. Divide by 7. X equals 9/7. Number 22, we have bases that are the same, so we can go 3x equals x minus 6. 2x equals negative 6. Divide by 2, and x equals negative 3. And finally, we want to get the bases the same. So 9 equals 3 squared. After doing some testing, we will find out that 243 equals 3 to the 5th power. So we have 3 squared with the 8x plus 1, and 3 to the 5th with the 3x minus 6. Distribute, so we get 16x plus 2 equals 15x minus 30. Subtract 15, we get x plus 2 equals 30. Subtract 2, and x equals negative 32.